Hello everybody, welcome to another math help video. This video is going to be on the operations with polynomials review to prepare us for, at least in my class, a quiz covering 8.1 to 8.4 from our book regarding adding and subtracting polynomials and multiplying polynomials. And there are some special cases in there too. I'm going to jump right in because I do not want to take forever. So the first problem here says, what's the degree and the leading coefficient? So that was something we did in our first section of the chapter. The degree is whatever the highest exponent is. So in this case, the highest exponent is 6. That's the degree. It's not necessarily in the front, just so you know. The leading coefficient is whatever number is in front of that. So the leading coefficient could have been 23, or it could have been -10, or it could have been 1. But the leading coefficient always is with the thing that had the highest degree. So in that case, it's this term. And there's no number in front of it seemingly, but you have to write something. So in this case, you're going to write -1. It could be +1, but in this case, it's -1 because that's what a negative in front of that means, a -1. I'm glad you got to see that -1. I said that when I did the assignment too, so here we go. Okay, next one. Highest exponent is, I see a 4, and the number in front, the coefficient, is 6, and I wrote that in the wrong box, so don't do like that. Sometimes they'll switch it up on you. So I'm glad you got to see that switched up. Make sure you read it. It's not always degree then leading coefficient. But I would start by finding the degree first. So I found the degree for, then I went back to the coefficient. Like once you know which thing has a degree, leading coefficient should be an easy follow-up question. All right, next it says simplify. Now this looks like a lot, and I don't want you to get confused. Sometimes you will need to multiply 3 things in a parenthesis times 3 things in a parenthesis. But when there is a plus sign outside of the parentheses, you are not multiplying anything. You are simply adding them together. And when I say adding them together, I mean you are just adding them together. You're adding the like terms. So let me write it out on this one. If there's a second one of these, I definitely won't be writing it out. So when I say adding the like terms, I mean like here's a like term, and there's a like term. T's are a like term. Numbers are a like term. Notice I'm putting extra underlines. So 2t squared plus 6t squared is 8t squared. Don't change the exponent. We've had a lot of opportunities where exponents should change recently, but not on these. -3 and -4t make -7t, and -7 plus 5 makes -2. That's it, you're done. You're just simply adding the like terms. Now, I don't know what the probability is that you're going to see a minus sign in between these, and you totally could. But I feel like Alex dropped the ball by not putting that stuff on these. What I do, oh, I wrote 2t squared, not 8t squared. Dodoy. Oopsies, usually I catch that before hitting the enter button. Always read your answer. Okay, so anyways, I was too busy talking about my sentence. So what I'm saying is you can get a negative sign between these, and if that's the case, you got to go through a whole different process. Like you got to flip all the signs on the second parenthesis, then add the like terms. But in these cases, you could do this. You don't even need to show work. Like, is there really work to show? Just think in your head, -4x squared plus 1x squared, -3x squared. Here, by writing it here, I'm less likely to make a mistake now. 6x plus 2x, 8x, -5 plus 7 plus 2. Simple. Now, if you had gotten a negative, I hope you don't get confused. You would flip all the signs of the second parenthesis only, and then combine the like terms. It's one extra step. I never saw it on the homework. I don't know why. The what do you call it? The property that I put said add or subtract polynomials. So I'm shocked I'm not getting subtract. Okay, next one, you got to distribute. This is multiplying. Although this isn't multiplying two polynomials, it's a monomial, 5a squared, times all this stuff on the inside. So boop, boop, boop. Okay, a little bit better. Append that. Okay, 5a squared plus 8a, that's 40, a to the third. Notice the 2 adds with the 1. It's not written, but it does count as 1, so don't forget to add 1 for that. Then we got 5a squared times 4a to the 7th. 5 times 4 is 20. and a2 and a7 add those exponents to make a to the 9. So my final result was 40a to the third plus 20a to the 9. So it's just distributing. You just have to remember that if you distribute a thing with exponents into other of the same variable, you'll have to add the exponents together. Same thing here, and I will attempt to skip the work here. Negative 2 times 2, negative 4. W to the 5th and W to the 2nd make W to the 7th. Negative 2 and negative 6 make positive 12. W to the 5th and W make W to the 6th. Make sure you add 1 for that. And then negative 2 times negative 3 is positive 6. And then W to the 5th, because you got to append it on there. Notice as I did those, I only worried about, as I did it in like minor parts. Like I did number times number, wrote that. And then I did variable times variable and wrote that. I feel like that's a good way to like slightly break it down. Don't worry about too much at once. Just go back at the end and make sure it's all there. All right, here's another one of those. This one has the distributable thing on the back end. It could go either way for you. Now, what I would recommend is if it is on the back end, you rewrite it like this, maybe on some work paper or something like that. And then you write it down here. Okay, so the back guy is now in the front. And that's going to distribute into two things. There's a lot of letters and number jumbled up here, so be careful. Let's take it one piece at a time. Negative 7 times 4, negative 28. A times a squared, a to the third, b fifth and b sixth, b to the 11. Then you got negative 7 times negative 5, which is positive 35. A times a to the fourth is a to the fifth. And then there's no b, but I do need to include the b that I was distributed in, which is b to the fifth. Now, if you're concerned about if these are like terms or not, they're not. They have to have the same letters with the same exact exponents, which these guys have all kinds of different exponents from each other. So don't worry about that. B to the 11. Now you got to go through the arduous process of typing that all in. A to the 5th, B to the 5th. Just make sure very carefully you've done it all in the correct steps. One wrong letter, sign, etc. could spell disaster. Oh, dude, we're halfway done? Cool. And now we're back to some, well, I don't know who would be watching this all in the same night. I definitely made all these videos in the same night. So now we're back to some multiplying polynomials that don't look so complicated. But they are, whoopsies, didn't mean to click that. They are going to be, you know, something I hope you know the process for. So, but the process had two options. Option one was foiling, where you do first, outer, inner, last. Option two was to make a box. So because I saw the next problem was the same thing, here I'll foil. So v times v, v squared, v times 3, 3v, negative 4 times v, negative 4v, negative 4 times positive 3, negative 12. You got like terms in the middle, so I get v squared. These guys, 3 minus 4 is negative 1, so I'll write negative v. You should not write negative 1v. I think Alex could get mad at you. I don't know if it'll mark you wrong. It has been known to in the past, but it's just better if you don't. Okay, so that's option one. You can foil. So you'll get 4 different results. You'll add the like terms in the middle together. Bada bing, bada boom, right? So here's another one of the same thing. Yes, I put two of them on the review, and therefore 2 of them are on the quiz. Spoiler alert. I wrote really small here. Hopefully you can see it. I wonder how good of quality this does it in. It says it's like 720p, and then it looks like 360p. All right, u times u is u squared. 6 times u is 6u. Negative 4 times u is negative 4u. And negative 4 times 6 is negative 24. These are the same 4 things I would have got by, you know, foiling. And you would have got the same 2 like terms in the middle. But this just helps organize everything. So I got u squared plus 2u minus 24. U squared plus 2u minus 24. Next. We're cruising, sub 10 minutes. Okay, more of the same. Now, if you've been watching any of this, in conjunction with any of the other videos I made recently, You're probably like, wait, where's the special cases or whatever? We haven't seen a special case yet. If you're not sure if it's a special case, doing what I've been doing on these problems is always a good option. Just so you guys know. So here's this one. 5x times 8x is 40x squared. 5x and negative 1 is negative 5x. Negative 2x and 8 is negative 16x. And negative 2 times negative 1 is positive 2. And these are like terms, as usual. They're not always like terms, but often they are. The only time they wouldn't be like terms is if you had like 5x plus 2y, and then you didn't have a y anywhere else in the problem or something like that. It's possible, but they just don't do it very often. I'm not saying you couldn't see it in your life, though. Okay, moving on. All right, I'm going to write this one right in the box because I'm getting lazier. 3y and 2y make 6y squared. 3y and negative 7 make negative 21y. 5 times 2y is 10y. And 5 times negative 7 is negative 35. You can't leave it with these two guys in the middle. They must combine. So negative 21 plus 10 is negative 11y. So there, you can do all your work right in the row. Yeah, I'll do it again. 3x times x, 3x squared. 3x times negative 6y is negative 18xy. Yes, notice this one has two letters, so I'm going to be writing some multi-letter stuff. Negative 2y times x is negative 2xy. You could write yx, but I'm going to write xy so I can definitely show you they're the same kind of term. Plus 12y squared. I'm doing plus because it's a negative times a negative. Okay, can't end it here. I got to combine the middles. Negative 18 and negative 2 make negative 20xy. So same thing I was doing. This one had two letters in it. Big whoop. All right, now as we get to the end here, we're going to see some special properties. So now here's the deal. If you don't know it's a special property, no one's going to stop you on the test from going v minus 4, v minus 4, distribute like this. Like, no one's going to stop you from doing that. If that's the way you want to do it, as long as you know to write it out twice, that's good. What you can absolutely not do is just put v squared plus or minus 16, because that is not supposed to be the answer. The answer is supposed to be v squared negative 8v plus 16. And you're probably like, hey man, you didn't even bother multiplying it out. How'd you get that? Well, this is a special case. So on my special cases video, I fleshed it out a little bit more, but the gist of it is this. When you see one singular thing squared, you can go right to the answer by doing the first thing squared, so v squared. The middle term is v times negative 4 doubled, so negative 4v doubles to negative 8v, and then negative 4 times negative 4 makes positive 16. So you can skip some work by doing that property. I'll try and show you on this next one here. So I say, oh look, a singular thing squared. So the first term is 3y times 3y, which is 9y squared. The middle term is the tricky one. 3y times 4w is 12, but we're going to double that to 24. wy, and then the last term is 4w, so we're going to do 4w times 4w, which is 16w squared. Okay, what problem are we on? Oh, two more. All right, so all those ones were singular things squared, so the property was first thing squared twice, their product in the middle, and then the last thing squared. Now this one's a little different. This isn't one singular thing squared. This is two different things from each other. These are called conjugates. Well, they're not two different things. They're like the same thing, but one has a plus and one has a minus. That's called a conjugate. So you can do all this out, blah, 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 but I will cut right to the chase. The fast way to do this, if you see it's this special case, and only in this special case, you say, ooh, first thing squared, u times u, and then last things together, negative 3 times 3. You don't have to do, you're like doing the F and the L of FOIL. You don't need to do the outer or the inner. The reason why is because, oops, I didn't even write this correctly. If you did the outers, you'd get 3u, and if you did the inners, you'd get negative 3u, and they would have canceled out. So when you see one of these special cases called the conjugate, you're allowed to skip doing anything besides the first times the first and the last times the last. So let me show you here. So this one has 5y and 8z, 5y and minus 8z. So it's a conjugate, right? So you say, okay, 5y times 5y is 25y squared. And you say 8z and negative 8z is negative 64z squared. And I skipped doing any of that middle stuff. Again, you could do it, like if you write it out and you work it out, fine, it doesn't matter. You'll get negative 40yz and positive 40yz, and those things would have canceled out, and you would have been fine either way. And that's it. Oh, 15-minute video. Delightful. I hope it's a 15-minute quiz for some of you. I mean, I was explaining myself too. Oh, I hope it's a 15-minute quiz and you get 100. Okay? If it ends up being a 45-minute quiz and you get 100, that's fine too. If it ends up being a 55-minute quiz and you get 100, that's fine 3. And if it takes an hour and a half and you still get 100, that's also fine. All right, so anyways, here's the problems. Number 1 and 2 were, what's the degree and the leading coefficient? The degree is the highest exponent, and the leading coefficient is the number out front of that term. And don't be careless, like I almost was on number 2. Degree and leading coefficient aren't always asked in this order. On 3 and 4, we added 2 polynomials together, so that was just simply adding like terms, the squareds, the regulars, and the numbers. Simple. Number 5 and 6 was us distributing into parentheses with a monomial to a polynomial, so we had to add exponents, multiply numbers. It got a little more complicated as we moved on. We ended up getting 1 with a thing on the back with multiple letters that needed to go backwards, so I wrote that thing first and then put them into it. Then we had a few multiplying 2 binomials together, which is multiplying polynomials. This is a very common thing we're going to see a lot of, or the reverse of this. So we multiplied these guys. We did the FOIL method on some. We did the box method on one. Then I just started putting them right into the answer box. Here's some with numbers in front of the first variable. Not really a big difference. We got even more of those. Scooting along. Number 12, same way. That one had 2 letters. 2 letters, same thing. Okay, then we had some special cases. So one special case is when you have a single parenthesis squared, it's first term squared, double their product, last term squared. And if you don't remember that, it's fine. Just get a 2x2 box out and then do v minus 4 times v minus 4. Or do foiling with v minus 4 and v minus 4. Did you hear that? That's on the video. That's going to be me freaking out for like 1 second. I set an alarm for 9:20, which it is now 9:20. All right, moving on. So then we had more 2-parters squared. So that was same properties. Again, you could write 3y plus 4w, 3y plus 4w, FOIL it, box method it. It's all the same thing. It still works. You don't have to remember the property for that. Then we had the conjugates property, which said you only have to do first times first and last times last if you have 2 things that are the same but with different signs. So that's an option. Or if you want to just put it in the box or FOIL it, you still get the same answer. Nothing wrong with doing that way too. Whew, okay, that was a mouthful. I was really going fast. And I was trying to beat the alarm, but I barely managed to not beat the alarm. That's okay though. Don't always beat the alarm. So that's the end of that review video. I hope you found it helpful, and I'm going to try and post this early so you can get an entire day to watch it at least prior to the quiz day, if you're in my class, that is. And that's it, man. I'll see you on the next time.